Dear students, good morning. Let us see the course Dynamics of Machinery, that is DOM. Let us see the topic balance. Okay. At the end of this session, you will be able to develop knowledge of analytical and graphical methods for calculate balancing of rotary and reciprocating masses. First of all, what is balancing? Here, as you know, the high-speed engines and other machines is a common phenomenon nowadays. Therefore, very essential that all the rotating and rotary reciprocating parts should be completely balanced as far as possible. If these parts are not properly balanced, the dynamic forces are set. These forces not only increase the loads on bearings and stresses in various members, but also produce unpleasant and even dangerous vibration. Okay, so you must balance those machinery. Otherwise, vibrations will produce and the lifespan will be reduced. Okay, so you should balance those engines. Okay, let us see the course content. Before that, this is the common phenomena in steam turbine rotors, engine crankshafts, and rotary compressors, and centrifugal pumps. In all these, you can observe vibrations if there is no proper balance. So you should balance both reciprocating and rotary masses. Okay. Let us see the course content. Static and dynamic balancing of rotary masses, force balancing of 4-bar linkage, primary and secondary balancing of reciprocating engine, balancing of inline four-stroke engines like 2, 4, 6 cylinders, V engines, 3-cylinder radial engines, direct and reverse crank method, introduction to wheel balancing and also wheel balancing. Now, this is the content. Let us see one by one. These are the applications. Like when the course contains, you have to see. The first one is the rotating masses. These two are the examples. See, this is the turbine blade. These two are the rotating masses. Here you have to balance the rotating masses. This is, see here, this is the reciprocating engine. So reciprocating parts should be balanced. This is the multi-cylinder engine. It's an inline engine. That means all are having same crankshaft in a single line. See here. This is the inline engine. Multi-cylinder inline engine. Okay. This is the multi-cylinder V engine. Okay. This all should be balanced. This is the radial engine. Okay. Let us see. Static and dynamic balancing of rotating masses. Okay. As you know, when machine is working condition, different forces are acting on it. It may cause damage to vibrate and cause damage to machine parts. The different forces acting on machine parts, static forces and dynamic forces. Okay, that is the static force. The name itself, the force which depends on weight of a body is known as static force. Depends on only weight of the body. Okay. Generally, static force acts when vibrations occurs in same plane. Okay. Similarly, dynamic or inertia force, the force which depends on acceleration of a body is known as dynamic force. Generally, dynamic force acts when vibrations occur in different planes. Okay. Due to these forces, the efficiency of the system decreases and lifespan of the system also decreases. So all are due to vibrations because improper balance. Okay. Due to those forces, the machine starts vibrating, and sometimes when the vibrations increases, the machine would lift from its position to its position and cause damage to other machines or human. So to avoid this, foundation is made below the machine, as you can see in this figure. Here, some foundation is there. Okay. So to avoid this, foundation is made below the machine. See, as shown in the figure, which observes the vibration, and protects the machine against causing damage. Thus, thus balancing of the machine is required. Okay. As you know, the balancing is the process of eliminating the effect of static forces and dynamic forces on machine components. That is the static balancing. A system is said to be statically balanced. Name itself, statically balanced. The center of masses, center of gravity of the system lies on the axis of the rotation. Okay, should be in the system lies should be on the axis of the rotation. Condition: the resultant of all centrifugal forces, that means dynamic forces, acting on the system during rotation must be zero. Okay. That means the centrifugal forces acting on the system is equal to zero. Okay, that means mr omega square minus mr omega square is equal to zero because the summation should be equal to zero. Here we only have centrifugal forces. Coming to dynamic balancing, the system is said to be dynamically balanced if it satisfies following two conditions. The condition one is the resultant of all the dynamic forces acting on the system during rotation must be zero. Dynamic forces must be equal to, that means summation of dynamic forces acting on the system is equal to zero. Next one, the resultant coupled due to all the dynamic forces acting on the system during rotation about any plane must be zero. That is, summation of couple must be equal to zero. If it satisfies these two conditions, this is nothing but dynamic balance. Okay, this is all about static and dynamic balancing. Okay, in exam they may ask to explain static and dynamic balancing. Then we can write this answer. Okay, thank you. So like that, you have to write the answer for that question.